All right, I'm going to do this time that tricky u substitution where we end up with an extra term left over. So, oh wait, this isn't number 10, sorry. Problem number 17 on the page is the definite integral from 7 to 10 of x over the square root of x minus 6 dx. Just because of what we see, what we have downstairs, we have a square root in the denominator. You definitely want to set u equal to the thing inside the square root. And conveniently enough here, your du will be equal to dx, or rather that might seem inconvenient because that doesn't get rid of this x term here. If I start to replace variables, I have the square root of u now on the bottom. My dx becomes my du, but I still have this x term here, and you can't take the integral when, at least you don't know how yet, until all of these are in one variable form. You can't have x's and u's in the same problem. So what we're going to do is we're going to come back over here and we're going to use this fact that we established for u to say, well, if u is equal to x minus 6, that means that u plus 6 is equal to our x term. And we can substitute this in now. So we'll now have the integral of u plus 6 all over the square root of u du. And you'll want to do some algebra on this before you take the integral. This isn't something you'll want to do the u substitution on again. You definitely can't take the integral as you see it. So use the fact, use your power rules. You know that this down on the bottom is equal to u to the 1/2 power. And you know that when you divide things that are of the same base, you're going to subtract what's in the exponent place. So this is u to the 1st power, and we're going to subtract u to the 1/2 power. So that will give us u to the 1/2 here. And here they're not of the same base, but we can bring the u upstairs and put it with the 6 if we make it a negative power. And now that it's in its power form, it's going to be much easier to take the integral of this. We've got u to the, we're going to add 1 to the power, then we're going to take that power and flip it upside down, put it in front. And then for the next term, we're going to add 1 to the power, then we're going to take that power, flip it upside down, put it out front. And let's see, this is a definite integral, so I won't put in the plus c term here. Let's go ahead and simplify this and put our x's back in. So we had x minus 6 to the 3/2 power plus 12 times x minus 6 to the 1/2 power. And I don't really have room, but I'm going to make sure I put my bounds back in. So I'm going to take the upstairs, or the upper bound, plug that in first. Always the upper bound subtracting the lower bound. It doesn't matter if the upper bound is smaller. I had somebody ask me about that question yesterday. It doesn't matter which one's bigger or smaller. It's always going to be whatever the top one is minus the bottom one. So we're going to have 10 minus 6 to the 3/2 power plus 12 times 10 minus 6 to the 1/2 power, and all of that minus 2/3 7 minus 6 to the 3/2 power plus 12 times 10 minus, oh sorry, I was looking at the wrong spot, 7 minus 6 to the 1/2 power. And this will simplify fairly nicely for us. On the basic skills test, you can choose how much you want to simplify. I'm not really going to be looking to see what your arithmetic knowledge is like. I'm more interested in seeing how well you do the calculus. So if you want, you can stop here at this step. But if you get anxious over seeing your problem look like that, and if you're doing an actual application problem, go ahead and simplify. I'll go as far as I can in my head. Okay. Oh, I just noticed I put an extra set of parentheses. I'm going to erase these. I shouldn't have this parenthesis here. I should have put it out in front because I don't want to multiply the whole thing by my 2/3. I do want to multiply just the 4 by the 2/3. All right, so 2/3 times the square root of 4 is 2, and now we're going to take 2 to the 3rd power. So here we're going to have 8. And again, the square root of 4 is 2, so this will be 2 times 12, which is 24. Oh, I can see I did the same thing here. I'm just used to putting that constant out inside of the parentheses I can see. It's habit. I could go back and redo this whole video, but I don't want to. So I always love taking 1 to any power because it's always just equal to 1. So here we just get that 2/3 plus 12. And do what your grade school teacher taught you. Put common terms together. Right now we have 16/3 minus 2/3. And we have 24 minus 12. I like to think that that idea of common terms, collecting like terms, goes for more than just your x's. So we have here 14/3 plus 12. I can make this one look like a fraction if I multiply by a special form of the number 1 so that I have a common denominator. And then I put together the numbers that are in the numerator, and I get 50/3.